All right, problem 80. We're given that the function f of x is equal to this, and we need to find the value of x on this interval from 0 to 4 so that you have the average rate of change on this interval equal to the instantaneous rate of change. Okay, so let's look at what the average rate of change would be. Let's just write average, keep it short. This is basically what you learned in your algebra days, where it's going to be basically the slope from the endpoints. So we're going to have f of 4 minus f of 0 over 4 minus 0. Just saving some time with the calculations. And you would get, I'm punching this in, kind of glary, but you can see it's about negative 0.36. Now you want to find the instantaneous rate of change when it's equal to negative 0.36. So the instantaneous rate of change is basically the derivative. So f prime of x. So let's take the derivative of this using the properties of the exponentials and chain rule. We'll have the negative sign of x times e to the cosine of x minus the cosine of x as our derivative. We want to find when is this equal to about negative 0.36. So the way I went about this is just making a graph of this function, of the derivative, quite literally. So I brought up my graph here. It's a little tough to see, and I guess depending on whatever calculator you have, you may have a different, screen looking or syntax or whatever, but that's independent of what we're trying to figure out. On this calculator, you can see over here. Let me move over actually. Oh yeah, no, sorry. There it is. That's in the blue down here. So you can see if you're looking at the blue, see the y value is about negative 0.36 and the x value is 1.9. So we want that x value 1.9. Zooming back out, and so the answer will be B. All right, 81. Let f and g be differentiable functions such that f of g of x equals x for all x. If f of 1 equals 3 and f prime of 1 equals negative 4, what's the value of g prime of 3? Okay, so when you're given that f of g of x equals x, this is showing that f and g are inverse functions. That's quite literally how an inverse works. You undo one function to get the input. So then we can use the derivative property or formula maybe if you maybe had to learn that way, but that's usually the quickest, simplest way. So you can just remember this, that doesn't matter which one you call f or g, just have one of them be g. G usually represents the inverse function, but again, it really does not matter because you can just solve for one if you're given the other. And so if we're trying to find g prime of 3, you can set g prime of 3 equal to 1 over f prime of g of 3. F prime of g of 3, we're told that, so we're told here, we're told that f of 1 equals 3. Since f and g are inverses, that means g of 3 is 1. That's how an inverse works, going from the input to the output and output to input. So f prime of 1, then we have 1 over f prime of 1, which we're given that f prime of 1 is negative 4. So negative 1/4 is our answer. Right, 82. Okay, this is one of those like conceptual picture ones. So for this one, we're given the graph of f, and we need to figure out which one of these graphs below could be the graph of its derivative. So I usually use work in the sense where you want to just understand the sign of the derivative. So we look at basically when it changes from increasing to decreasing. So on this side, it's increasing, so the derivative is positive from here to here. From here till here, the graph is decreasing, so the derivative is negative. Then from here to here, it's increasing, so it's positive again. And so we quite literally want to see what can first match. When we want a graph where it's like to the left or below -1.5-ish, it's going to be positive. So you can right away see it's not going to be this because it's not positive till less than -1, so it's not A. Same thing with B. It's not positive below -1, so it's not going to be B. Right, so C and D, they're both positive till less than -1. So let's do this. Let's draw like a vertical line to kind of see where I'm getting at. And so you can see how like at the point like let's say -1.3, it changes from positive to negative. But for this graph, it stays positive all until 0, or let's say it's positive all the way until like 0.5. So it's not this one. It's gonna have to be D, because that one changes from positive to negative here, and it changes back to positive over here. So the answer is D.